Folks, let's take a look at problem 10.7. Okay, what I would like to show you in this problem is that when you plot the data, okay, especially when you have a data like for past several years, we have the quarterly information, quarter 1, 2, 3, and 4, or it could be past several weeks, and each week of the day could be listed here like Monday through Sunday. Okay, and when we have the data like that, so what we have to see there is there a pattern that we can see? Okay, like for example, now this quarter 1, 2, 3, 4, year 1 happened first, that is year 1, and year 2 comes next, that's year 2, then year 3 comes next, that's year 3. So quarter 1, 2, 3, 4 of year 1, 1, 2, 3, 4 of year 2, likewise. In terms of the time period, so going back to the data that we have of year 1 way back, so this is the oldest data, that is time progresses like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 onwards, it goes like that. If you plot the data of the actual sales that you have, like year 1, 4 quarters, year 2, 4 quarters, year 3, 4 quarters, against the time, you see the pattern here. Quarter 1 to 2, the sales dip, then peak to quarter 3, then go down to quarter 4, and go down to quarter 1 to 2, again dip, then pick up again in third quarter, go down, pick up again third quarter, go down. So quarter 3, the sales peak at quarter 3, and quarter 1 and 2, they basically go down and they pick up again. So this is a pattern that we see all the time, and that is because of the seasonality. Like, you have seen that during the Mother's Day or Father's Day, the sales pick up, and also towards the Good Friday and of course the Christmas time period, the sales pick up. So those are the seasonality. And many a times also you do hear in the news seasonally adjusted, the house sales, the home sales, or seasonally adjusted, the unemployment rate and all those things. What exactly do they mean by seasonally adjusted? Okay, we will get to that little soon. Okay, so what we see here is quarter 1, year 1, 2, 3, 4. If you look at it there, and you see the pattern picking up in quarter 3, going down and picking it up between 1 and 2. Okay, so this basically happens. So this is the rise and fall. The rise and fall of the sales is due to the seasonal effect. Like we all know that during Christmas period, the sales basically pick up, then they drop down again. Okay, so that is the seasonal effect. So we want to see how much of this the growth in sales is accounted by the seasonal factors. That's what we want to know. In other words, if we don't expect any seasonal effect, then what it says is there should be a sales that should be average, that should be more or less the same numbers for each one of these periods. The fact that the seasons are present either amplifies the demand or dampens the demand. That's the effect of the season. And what is that? So quarter 1, the way that we compute the seasonal factors is we take the average of 23, 19, and 21 and divide that by the overall average of this data that we have. What are our average quarterly sales for the last 3 years? So that is that formula here. Okay, so that is the average sales for the quarter 1 for the 3 years, that is D5 through F5, divided by the overall average quarterly sales for the entire 3 years. So that's the D5 through F8. Okay, I note here I have prefixed them with a $sign because I'm going to copy the formula down. So the average sales for the entire, quarterly sales for all 3 years is the same. So that's why that dollar, prefix there. That's 0.84. And likewise here, this is the average of quarter 2 divided by the total average for the entire 3 years. Okay, so here it says that on an average, quarter 1 sales are about 16% down. Quarter 2 are about, compared to average, it's about 8% down. And compared to average for the third quarter, the sales are about 20% higher. And quarter 4 about 4% higher. So there are 4 seasons. When you add the seasonal factors, they should sum up to 4, and because we have 4 seasons. Okay, if it is a weekly data, then it should sum up to, based on the number of days that we have in the week, either 5 days, working days, then it should sum up to 5. Okay, that's what we have there. Okay, now what I have done is I have taken this data here, I have transferred the data along with the seasonal factors. I have repeated them down here. Suppose if you don't have the effect of season, then what we should have seen, the actual for quarter 1 of year 1 should be that divided by the seasonal factor, so it should be more than 23. So that's that number there. Now copy the formula down, and that's what basically you see. Now look at over here. This is the actual data. The red line is the seasonally adjusted data, which is smoother than the actual one. So this is what it is. Suppose if the effect of seasons were not to be there, suppose if the effect of season was not to be there, instead of selling 23 units here, we would have sold 27.38 units. Same thing here, instead of 22, it should be 23.91. So that is the effect of the season. Once you take the seasonally adjusted, this is what it means is, when you take the effect of season out, you should be selling at an average about this. Okay, that's what you hear also. Seasonally adjusted home sales is, what is the average home sales you would have had if you were to take the effect of the seasons out. Same thing is for the economy. Okay, same thing is for the unemployment and all those things. So seasonally adjusted forecast data is what we look at. Okay, now the forecast based on the last value method here would be, the forecast for this period would be the seasonally adjusted actual value of the previous period based on the last value method. Copy the formula down, and let us decrease them to 2 decimal places. So this would be the forecast based on this. Now what would be the seasonally adjusted forecast? Remember that this forecast that we have is seasonally adjusted, so it has already taken out the effect of seasons from this forecast. Now we got to build the effect of seasons back into that, so that is equal to that times the seasonal factor for quarter 2, the respective seasonal factor. Copy the formula down. Then you see that this would be the seasonally adjusted forecast for each one of those quarters. So that means for quarter 1 of year 4, our forecast would be 22.62 units. Now let's go ahead and compute the mean absolute deviation, mean squared error, and MAPE as what we had done before. That equals the absolute, the error is between the actual and the forecast. So the actual is that minus the seasonally adjusted forecast would have been that one, and the percent error is equal to that value divided by the actual. Actual is that, express that as the percentage. Let's go copy the two for both of these formula downs. So that's what we have. Let's go to increase the decimal size 11.5%, and here let's go and then maybe decrease to 2 decimal places. Okay, that one. So the mean absolute deviation, MAD, equals the average of the absolute errors then MAPE equals the average of the percent errors, let's see, MAPE. Then MSE, mean squared error, equals the sum square of the absolute errors divided by the number of errors, that is, take the count of how many error points do we have. That's the mean squared error for this problem. Okay, part A of the problem is the forecast for quarter 1 is 22.62. Folks, part A of the problem is what are the seasonal factors for each quarter that we determined here, and part B of the problem is based on the last value method, based on what is the forecast for the quarter 1 of year 4. So the seasonally adjusted forecast is 22.62. Part C of the problem is to take this seasonally adjusted forecast as though that's a true, actually seasonally adjusted, the true value of actual, and based on that build the forecast for all 4 quarters of year 4. In other words, so 22.62 seasonally adjusted forecast would be nothing but 22.62 divided by 0.84, that's the seasonal factor. Okay, so that is 2692. 2692 then would be the forecast for quarter 2 of year 4, and multiply that by the seasonal factor 0.92, that is 2477. Okay, 2477 would be the seasonally adjusted forecast value for quarter 2 of year 4. Okay, now if you take the effect of the season out, so that is this value that you get, 2477 divided by 92, so that is that value. Now this value then would be the forecast for quarter 3, and actually would be 2692 times 1.2, that is 3231. Okay, seasonally adjusted true value would have been 3231 divided by 1.2, 2692. That becomes the forecast for quarter 4. Okay, now you adjust the seasonal factor, that's 1.04 times to 26.92, that's 28. So the quarterly forecast for year 4 would be 22.62, 2477, 3231, and 28. Okay, that's the part B of the problem, and I will just mention part B right there. That's the part B of the problem. And also I will color the same yellow here, meaning that all that thing yellow that's there is with respect to part B of the problem. No, this is not part B, I'm sorry, part C. Part B was just the first quarter. Okay, so this is part C of the problem. Okay, now part D of the problem is for part D of the problem is based on his assessment of the current state of the housing market, RAF's best judgment is that the agency will sell 100 houses next year. Given this forecast for the year, what is the quarter by quarter forecast according to the seasonal factors? Okay, so for the next year they say they average about 100 is what they're going to sell. So that means per quarter average sale should be 25 houses in each quarter. Quarter 1, 2, 3, 4 of the next year. Seasonal factors are, again, we have computed them, repeated here. Average sales is 25 units each. Then seasonally adjusted forecast value would be equal to the average sales times the seasonal factor. Copy the formula down. So we, RAF should expect to sell 21 houses. That would be the actual forecast for quarter 1. So average is 25. This is below average, so that means this number should be less than 25. That's 25 times 0.84. Likewise, less than 25 because this is below average sales, more than 25 and more than 25. That's part of the problem. Now, here I have shown you how to compute the seasonal factors and apply the seasonal factors to deseasonalize the data, that is seasonally adjusted forecast, and use one of the forecasting methods. So here it is last value is what is asked for in the problem, and if it is any other method like averaging method, you got to use the averaging method forecast. If it is a moving average, again do the moving average, exponential smoothing, whatever the method that's asked for, apply that over here and continue what we did before. Okay, now this concludes the how to compute the effect of the seasons, deseasonalize, then make a forecast, then build the effect of the seasons back into the forecasting method.